Hi everyone, this is Umakant. Welcome all of you to my channel. Here I am with some of the short tricks for central force motion. So as you know, central force motion is one of the most important chapter from classical mechanics, and question can be expected from this portion. So let's talk some of the important short tricks. Okay. So here I have to mention that as you know, behavioral theorem is one of the important theorem from classical mechanics. So as for this theorem, if potential V of x is proportional to x to the power n, then you know the kinetic energy, the average of the kinetic energy is nothing but the n by 2 of potential energy. And from this section the question can be framed into different kind, that is the ratio between kinetic energy and the total energy of the system, and the kinetic energy and potential energy ratio can be asked. So several questions can be asked from here. And you know, if any potential, that is if any central force is given to you, f of r is given to you, then you know the force is always negative gradient of the potential, so f is equal to minus dv by dr. So if potential is given, then you can find the force, and if force is given, then you can find the potential by making integration of the force, okay, over dr. So this is the general thing. If potential is given, then you can find force, and if force is given, then you can find the potential. And the important question that mostly asked is about you have to find the time period for any given potential. If some potential v of r is given, then they will ask to find the time period or omega or frequency. So as you know, the omega, that is angular frequency, which is equal, omega is equal to 2 pi by t, or is equal to 2 pi of f. Okay. So if the potential v of r is given to you, so you have to find the force, that is f equal to minus dv by dr. And at equilibrium, you know the total force of the system is 0, that is f equal to 0, and you make this dv by dr is equal to 0 at equilibrium point r equal to r naught. Okay. So you will find the equilibrium distance r, okay, or r naught. So once you get the equilibrium distance r naught, then you have to find the spring constant k, that is the second derivative of this potential, d square by dv square, dv square by dr square, at this equilibrium point r equal to r naught. So if you have this spring constant with you, then your angular frequency omega will be k by m by root over. So you can get this angular frequency omega, that is equal to k by m root over. Okay, this is one kind of question, and mostly this kind of question is asked for 1 marks in gate. Okay, so please go through it. Then one of the important question is from reduced mass concept, is from reduced mass concept. So you will be provided with two mass, that is m1 and m2. So you will be asked to find the angular frequency. So in order to convert this two body system into one body system, you have to use the concept of reduced mass. That's it, mu is equal to m1 m2 by m1 plus m2. So once you have this reduced mass with you, so you can find the omega, that is k by m root over, or k by mu root over, because here mass will be reduced mass. Okay, so this is one kind of question. So next, the people several time asked about a question from effective potential. So they will give you any kind of potential v of r, and they will ask to find the time period or omega or frequency. But here the potential will be different kind. So no, for any potential v of r that is proportional to r to the power n, this is very important. If any potential v of r is proportional to r to the power n, then no, the time period t will proportional to energy to the power 2 minus n by 2n. This is very much important. This is very much important. Please note it. If the potential is proportional to r to the power n, then the time period t will be proportional to energy to the power 2 minus n by 2n. And if there is an amplitude term a here, okay, so proportionality will be converted to equal. So if amplitude term is there, then this time period t will proportional to this amplitude a to the power 2 minus n by 2. Okay, so this is the formula or the short trick, that is the relation between time period and energy, and the relation between time period and amplitude. Okay, so this is one of the best question you can consider. This is very important short trick. Okay. Then from central motion point of view, you can neglect the concept of effective potential. So effective potential very much important. That is equal to L square by 2 mu r square plus V of r. Okay. So this is important, this concept is important, and also go through the intensity, the high parabola, circle and ellipse and eccentricity. Okay, so this is very important. Bounce orbit and unbound orbits energy, very much important for any given potential angular momentum. And this is important, this portion is important for central motion point of view. Then there are important shortcuts for small oscillation also, so please go through this. This is very important, and 1 to 2 questions can be expected from this portion from classical mechanics point of view. Okay, so thank you so much, thank you for watching my video, and I will request to all of those who are new in my channel, so please subscribe my channel, like my videos, and share my video if you think it is helpful to you. So thank you so much.